All right, this video is for the Ready portion of the Unit 3, Lesson 3 Ready, Set, Go practice. And at the top, please put your name. Okay, so in the Ready portion of this, we are asked to fill in the table of values for each of the linear functions. So we should be able to recognize from the way the explicit equations are written that these are linear functions, but we're also told that. And then we are asked to state the point of intersection of the two lines. I just want to make a quick note here that we cannot always tell where lines intersect from a table. Sometimes we can, sometimes we can't, and we might dig into that a little more. But for now, I'm going to go over problem 1 a little bit slowly for anyone who might need help. So when I look at this equation, I might recognize that it is in y equals mx plus b form. So I already know my y-intercept is -5. So I could use that form of the equation. In fact, how about this? For this first function, I'll do this. Let's use that form of the equation to fill out the table. So if my y-intercept is at -5, that's the ordered pair 0, -5. Remember, f of x is always your y value. It's just function notation, so I put a -5 in my table. So that row of my table represents the ordered pair 0, -5. I can also tell that my slope, represented by the letter m, is the number 3. Since it's positive, that means that as x increases by 1, y is increasing by 3. And we know we are adding a 3 each time. So -5 plus 3 is -2. -2 plus 3 is +1. +1 plus 3 is 4. And 4 plus 3 is 7. Now we could also we could fill out the table for g of x in the same way, since this is also in slope-intercept form. Remember, when there's not a number in front of x, there is a coefficient of 1. And remember, the word coefficient is the number that we multiply a variable by. So 1. But we could also, if you're having trouble using the slope-intercept form, we could just evaluate g for each of these x values. So when I plug in 0 for all of my x values, I get that g of 0 is 1. When I plug in 1 for my x values, I get 1 plus 1, which is 2. So g of 1 is 2. When I plug in 2, I get 2 plus 2. Oops, nope, 2 plus 1, not 2 plus 2. 2 plus 1, because this one is a constant, which is 3. And so when I plug in 3 for my x values, 3 plus 1 is 4. And as you can see, the pattern continues. So if I'm looking for a point of intersection, I'm looking for a point that would be the same on both of these functions. So I notice that both the function f and the function g have the ordered pair 3, 4. So if we were to graph these functions, they would intersect at the point 3, 4. All right, I'm going to pause the video and I'm going to fill out the table for number 2. You should pause the video and try number 2 on your own if you haven't already. All right, here's what I got for the functions f and g in number 2. And when I filled out the table, I just mentally added 2 to my x values for f of x. So when x is 2, I added 2 to that value to get 4. For g of x, I know my y-intercept is 0, or I could just double my x values. So for g of 2, for example, 2 times 2, when x is 2, 2 times 2 is 4. Now, in this table, you weren't given x values, so I just used the same ones from number 1, and we're not guaranteed to find the point of intersection when we do that, but in this case, it worked out. So 2, 4 is the point that both of these lines have in common. And when lines intersect unless the lines are the same line, like unless they're on top of each other, we call that collinear when two lines are on top of each other. Unless they're the same line, they're only going to intersect one time, but they could also never intersect. However, only parallel lines never intersect. If you think about it, a parallel line, or sorry, two lines that are parallel, I should say, would never intersect because they would have the same slope but different y-intercepts. All right, so we get our point of intersection. All right, so I'm going to ask you to pause the video if you haven't tried 3 and 4 yet. Try 3 and 4. I'm going to just continue to use the same x values. All right, when I just said I was going to use the same x values, I was looking at number 2 where we weren't given x values, but number 3 we actually were. So I didn't mean to lie to you, but I used the x values that were already in the table. So in both functions for number 3, I used the y-intercept first. So in slope-intercept form, I know my y-intercept is the ordered pair 0, -4. I put it up here at the top of my table, and then I use the slope, which is 3. So remember, in mx plus b, m is our slope, and I use the addition of 3 to fill out my table. In my opinion, that's faster, but we can always check our values by substituting 5 for x. For example, 3 times 5 minus 4 is in fact 11. So you could always use the plug-in method where we evaluate each point. I think you'll find it's more efficient if we don't. But in for G, I actually did use the plug-in value. So again, what I mean by plug-in value, excuse me, I am so tired. I substituted 1 for x, and I evaluated the function. Both these methods work. I think the method on the left is more efficient, but either method will help us complete the table. And I can still see in my table that my slope is -2 because I'm decreasing by 2. And I know my y-intercept should be at 0, 6. So if I think about it, 6 makes sense when x is 0, because when I decrease the value of 6 by 2, I get my next point, which is at 1, 4. So either method is valid here. Well, either method's always valid when we're using a linear equation. Oh, I'm sorry. So then when we're looking for our point of intersection, I didn't answer that question yet. I'm looking again in my table for where I have 2 ordered pairs that are the same, and it just so happens that it is 2, 2. So if we were to graph these functions, they would both be lines, and they would intersect at the point 2, 2. All right, for number 4, for both of these, I used the y-intercept method. So I found my y-intercept by looking at the equation, because again, these are all in y equals mx plus b form. So my y-intercept is the ordered pair 0, -9. And then I use my slope of 4, the coefficient of x, to fill out the rest of my table. If you do this method, it never hurts to just pick a value further in your table and check. So I chose the last value. When I substitute 5 into, I called this G. I'm so sorry. I shouldn't have done that. This is F. I'm not going to remake the video. You're just going to see me make mistakes too. We all make mistakes, and that's okay. We just got to be careful. So F of 5 is 4 times 5 minus 9. So when I'm finding f of 5, I'm just plugging 5 in for x, or substituting 5 for x and evaluating. If you do this method, just don't forget you've got to follow the order of operations. So we want to multiply before we subtract. I did the same thing for g on the right-hand side, and I checked the point g of 5 as well. So if I'm looking for a point of intersection, I see that it is at 5, 11. Now, these x values weren't filled out for us. So if you had started at 0, you wouldn't see the point of intersection if your table only goes to where x equals 4. So sometimes if we don't know what x values to plug in, we might have to keep going a little bit until we find the point of intersection. Okay, so we said our point of intersection is at 5, 11. And I believe that is it for the ready section of this assignment.